Okay, so now I'm going to the last question of exercise 2.4. For this question, the fighter jet is already traveling at a Mach of 1.2 while it fires a missile which is traveling at a Mach speed of 1.8 relative to the plane. So what does this mean is that when the missile, before the missile leaves the plane, the missile has already have a speed of 1.2. So that means when I fire it at a speed of 1.8, actually the missile has a total speed of 1.8 plus 1.2. Alright. So in the first question, alright, you realize that I actually add 1.8 and 1.2 to solve for the time taken. So the first thing you need to know before we carry on is that what does Mach means? 1 Mach, alright, is equivalent to 340 meter per second. Okay, so if the missile already have a speed of 1.2 here and adding 1.8 to it, so we get 3 Mach here. So that's why you get 3 multiplied by 340 give you 1020 as the speed. Now in this case we can use speed is equal to distance over time to solve for the time taken. Why? Because this missile is traveling at a constant speed. So this old formula is applicable and you get an answer of 4.9 seconds. Alright, so let's look at the second question. Second question, the first information given is that the plane's horizontal acceleration is 0.1 Mach per second. So this information is actually another way of expressing acceleration. It's like the amount of change in speed per second. So in order to convert this to acceleration that we know, which is meter per second square, you can just simply convert the 0.1 Mach to meter per second by multiplying by 340. So 0.1 multiplied by 340 divided by 1 will give you 34 meter per second square. So this is the horizontal acceleration. Now for the vertical acceleration is straightforward 0, simply because it is a uniform rate of descent as given in the passage above. Next, alright, the time taken for the aeroplane to return to its base is 166 seconds. Why? Because we are assuming that the speed remains constant at 1.7 Mach for the rest of the journey. Okay, so nothing special about it because again we can use the formula speed equal to distance over time to find the time taken, right? Because the speed is constant. So the last question is actually the one that you need to use area under the graph because the aeroplane decelerates. So because of that you cannot use speed equal to distance over time. So it mentioned that it starts at 80 meter per second and it took 5 seconds to decelerate. So from there you can find that the speed time graph will be defined by this shape. Alright, so the distance traveled will be half times 5 times 80. So the answer is 200 meters. Right, so this is the end of exercise 2.4. I hope that it has helped you